So let's do an example of chi-squared. So here, use the following information to answer the next questions. A teacher predicts that the distribution of grades on the final exam are here, and that's where they're recorded. So you see the proportion of grades where A's were 0.25, B's were 0.30, C's were 0.25, D's were 0.10, and F was 0.10. The grade frequencies, she had 5 A's, 7 B's, 5 C's, 1 D, and 2 F's. So my first step is find the observed values and find the expected values. So I'm going to go put all this in Minitab. And remember, I can do it pretty easily in Minitab. If you're not familiar with that, go back to the example videos for the PowerPoint, and that should help you with this. All right, and when I'm looking at it, let me notice one big thing before we go over. When I'm looking at those proportions, they're different. They're not the same. So that means I'm going to have to treat it differently in Minitab than if they were the same. So let's go to Minitab and let's do this. I'm going to do grade, and I'm going to do an O because that's my observed. Remember, let me do this. Before I even do that, let's back up and do grades. Remember, always put your categorical before you put anything else, your categorical data. So here we go. All right, so now I have grades. So now I want to do grades observed, okay? All right, so then I'm going to have, I had 5, I had 7, I had 5, 1, and 2. And again, I had 5 A's, 7 B's, 5 C's, 1 D, and 2 F's. So those were my observed values. Okay, now I want to do my grades expected. And remember, these are proportions, so I'm just going to put the proportions in. Oops. So that I have everything I need, I have everything I got from the problem, and I'm ready to go. Okay, so I've got, again, grades, grade observations, and grade expected. So if I go back to here, I can do the observed because the observed grades are here. I'm just going to copy and paste them because that's what they are. The expected is different because they give me proportions. So I need to solve for these values, right? And you can see here, I'm just putting words in there that I need to solve for the values. So I'm going to go up to stats, tables, chi-squared goodness of fit test, one variable. Okay. My observed counts. Remember, if I click in the box, it makes everything populate over here. I'm going to do this. I'm going to go ahead and put category names so I know what everything is. And I'm going to do by proportions, and I'm going to do it in the column, and I'm going to do this. Okay, so what I did, I've got my observed, I've got the names, actually the grades A, B, C, D, F, and I've got proportions by historical counts, and I put it in the column, so I'm calling for that column right here. See, here is here, so that's pretty easy for me to do. And then I hit OK. So what does it give me? I'm going to copy and paste this so we can take it back to the Word doc so we can copy it. Okay, so let's do this. I'm going to put it here. All right, so what does that give me? So remember those expected values that I wanted? Sorry about that. They're right here. So my expected value for an A is 5. My expected value for a B is 6. My expected value for a C is 5. D is 2, and F is 2. Now the thing that we're doing with chi-squared is I want to know if I gave it the expected based on my proportions. Are my observed and my expected, when I compare them, is there any difference between those two values? So it's going to go look for the observed of A and the expected of A, the observed of B, the expected of B, and so on. And that's how we get that chi-squared formula. To do that is we're comparing the observed to the expected, and then we get that chi-squared value. All right, so if I keep going down, it says, what are the degrees of freedom? So if I go back to my PowerPoint and I scroll down, because it gave me a lot of information, let me go grab this picture right here. I'm going to do this. I'm going to hit copy this picture. So then I'm going to put my next amount of values right here. Okay. So next question, what's your degrees of freedom? Well, I know my sample size is 20 because that was the number of observed values I had. My degrees of freedom is 4, so that goes right there. Okay, so I need to back up. Now I have my chi-squared value and I have my p-value, but I've got to figure out what my hypotheses are. So my null is the proportions are as followed. Oops, sorry, typos today. So I'm going to go back up here and I'm going to actually use these. I don't have to make it harder on myself. So what I'm going to do is this. I'm going to put this in here and I'm going to put the proportion of A, and I'm going to make this a little a to make my life easier. Proportion of B. And why am I using the P's? Because remember, I need the proportion that was given, not anything else. And then I'm going to finish here and the proportion of F. Okay. Okay. So this is my null. I'm going to put it on the next side. Maybe that'll make it easier. The proportions are as followed. And you can put the proportions in there. And I really do think it's kind of easier when you do that because I'm showing what I'm expected to be. And that's what I have. Okay. So now the alternative is, this is really easy. The proportions, oops. Sorry about that today, are not as followed. Okay. So I'm going to correct my spelling here again. Sorry for that. Okay. So the proportions are not as followed. Or, here's a huge or, you could do at least one proportion, oops, is different for what was given. Okay. Basically, they're saying the same thing. You pick the one that makes sense to you. So again, my null is that I believe that the proportions are how the observed data is going to act. That's what I'm getting. I believe that A's are going to happen 0.25, B's 0.30, C's 0.25, D's 0.10, and then F's 0.10. My alternative is that my proportions aren't going to follow that. Or I can say at least one of these proportions is going to be different. It's not, I can't make the assumption of which one is, but I know that at least one's got to be different. So if I keep scrolling down, it gave me my chi-squared value, which was, put down here, 0.666667. That's a big one. Or if I just want 3 decimal places, that would be good. Okay, p-value, 0.955. All right. So at the 5% level of significance, what can I conclude? All right, well, I need to go back up a step and I need to do my level of significance, which remember is the little fish. Let me go get it because you've seen it in all the other stuff. So let me go find it. Here's the little fish versus the p-value. So you need both those things. Remember my thing that I talk about? People, p-value, eat fish. Okay, so if it's going to be this sign, and I'm going to put my little fish in there from River Nile. Okay, so remember, p-value, if it's less than or equal to the level of significance, you reject the null. So that also means, I'm going to copy and paste it again, if the p-value is greater than the level of significance, I'm going to fail to reject the null. Okay, those are your 2 rules. Again, by this time you should be pretty familiar with them. All right, so p-value, I'm going to go down here and let's do 0.955, and my level of significance was 0.05. Again, I'm going to add another 0 there to help. So 955 is a lot greater than 50. So I put this in here, and so I fail to reject the null. Okay, so that was my thing. All right, so if I fail to reject my null, I'm going back up here. So this was my original claim, and it was true, and this is false. So what can I say? That the proportions do follow that. Why? I failed to reject my null, which means I was keeping my null, and my null was the proportions were going to be this, that an A was going to be 0.25, a B was going to be 0.30, a C was going to be 0.25, D was going to be 0.10, and F was going to be 0.10. All right, so I can conclude it. So at the 5% level of significance, the proportions of grades follow the distribution given. And you can always, if you wanted to, if you're writing this up, you might want to put what your proportions were. You could do a parentheses or whatever. But for this class, that's fine. You're given the level of significance, and then you're giving that it followed this distribution given. Hope this helps.